Okay, so these are the three equations that we're going to solve. Okay, and we're going to use the matrix manipulation to solve them, except we're not going to do this whole row echelon reduction to get all the way down to the answer. I'll show you the one that's slightly shorter than that. So there's no difference on the first step. You rewrite this in the matrix form. So you do, this is a 3 by 3, so you're going to get the coefficients go in one matrix, correct?
Yes.
So you get 1, 2, 3. Let's spread them out. We don't have to worry about paper here because, you know, we can get minus 1 because there's minus 1 here. 4, 5, and then here we're going to do 2, 1. We're going to do 2, 1, 3. Okay? And then times x, y, z. And that has to equal the 1, 2, 3. Okay, so yeah, okay. So what we're going to do is very simple. We're going to do the same exact operations we were doing, except, you know, you were making this as 0 and then this is 0. We're not going to really turn it into an identity matrix. We're just going to say we're going to make this part here 2 zeros. So we're going to leave out, because think about it, if potentially, if this guy was a 0, okay, potentially, if this guy here was a 0, for example, and if this guy here was a 0, then can't you say that 3z equals 3?
Right.
And then z would be 1. Then you could say, if this was the case, 3z equals 3, and then you'd claim that z equals 1, because 3 over 3 is 1. So that's the objective, is we're going to manipulate these two to make them a 0. We're not going to use an identity matrix or anything. We're going to do a set of operations on this to make these two zeros, and therefore the third number will be used to find the z. Okay, so the objective is to make these two as zeros because they're not zeros yet, they're 2 and 1. Okay, so for that we're going to do the same exact thing we've been doing. So we can multiply this by -2 and add it to this. So let's 1, 2, 3, those don't change. X. Now here you have to also carry whatever you change on the answer matrix, the solution matrix. We're not going to put an identity matrix. Okay, and then we have -1, 4, 5. I'm not changing the first two. Okay. And then the z here. Okay, now we said on the third one, we said we're going to do -2 times row 1 plus row 3. So that would knock this out, 0. So -2 times 2 is -4 plus 1. I'm doing -2 times row 1 plus row 3.
Okay.
So -2 times 2 is -4 plus 1 is -3. Agreed? Just the regular operation. On this on, and I'm changing the third row. Okay, and then -2 times row 1. So -2 times 3 is -6 plus 3 -3. And you also have to do it here. So -2 times 1 is -2 plus 3 is 1.
Okay.
Okay, now we made that a 0.
Right.
Okay, now the objective is to make this a 0. Okay, so let's go ahead and make that a 0. How can we make this a 0? So let's think about it. So we could do, you know, there's many ways. You could do this to be a 0. We could do, the only thing is we don't want to change this. That's the objective. So because if you change this, then you know we're back to square one. How can we not change this? So we can do let's see. So these two have to be 0. Oh, and one more thing. And also, if 2 here are 0s, you'd get the z, correct? Now, if this is a 0, you would also get the other two, the x and the y. So you knock these out, you make these two zeros, that would get you the z. Then you make that guy a 0. Let me put that in red. Why am I making this a 0? Because if I can make this a 0, then I would get my z from here, correct? And then this would give me an equation in y and z, because this would be, look, 4y plus 5z would equal 2. And if I have my z, I could find my y. Now, look, if this potentially, let's say that that's a 0. Can't you say 0 times x is 0? Just forget this, just from the first matrix. Plus 4y plus 5z equals a 2. Isn't that what this is saying?
Yes.
Okay, and you already got your z. Sorry, there's a z. You've already found your z. Z is 1. So you can put the z here and find 1. So potentially, if that guy was a 0, it would work out. So now I could make this a 0. How do I make this a 0? Simple. Just add the first two. Okay, so let's do that. So add the first two columns. So row 1 plus row 2, basically. So we would get, the first one doesn't change. So 1, 2, 3, x, 1. Right? And then here we're going to do row 2 plus row 1. So we're going to get 1 minus 1 is 0. Right? And then this plus this. So 4 plus 2 is 6. And then 5 plus 3 is 8. And we have a y here. Those you don't change, the x, y, z. And then 2 plus 1 is a 3. Okay, so this was row 1 plus row 2. Row 3 stays the same. So 0 minus 3 minus 3 z. Okay, so that was the second step. So far, so good?
Kind of.
What, did I lose you somewhere?
No, I just kind of.
Maybe it'll fill in. Maybe it'll, because it's the same thing, except it's a lot shorter. Because you'll see one more step and we're done with the question. Watch what happens. So now the third step is what I was telling you, to make this guy a 0. Now, what's the beauty of making that a 0 is when you use these two rows, you don't change this anymore. You could have done actually the second step on the first step and then did the second step, the first step on the second step. Doesn't matter. But the point is, these two zeros won't undo each other and they'll stay at 0. So now the objective is to make this guy a 0. So how do I do that? I could multiply this by half and add it to this. Okay, so then the first row will stay the same. Let's change the color. So 1, let's use green. So 1, 2, 3, x, 1, 0. Second two rows don't change. 6, 8, y, 3. it'll kind of get together the last step. You'll see the beauty of it because it's really like it cuts down a lot of work that you had to do on that other one. So okay, so now I'm gonna do row 2 divided by 2 because that would get me a 3 there, plus row 3 would get me a 0, plus row 3. Okay, now 0 over 2 is just 0, plus 0 is 0, so this guy doesn't move. Okay, doesn't change. Now this over 2 is 3 minus 3 is 0. That's the objective. I'm not trying to switch these to ones or whatever. I don't care. My objective, get first 1 0 on the second column, 2 zeros on the last column, and sorry, row, 1 0 on the second row, 2 zeros on the third row, and you're done. Regardless of what the other numbers are. So now here, row 2 over 2, that's 8 over 2 is 4. Notice there's no fractions too.
Right.
Although this is not an easy 3 equations, it's actually harder than the one we did. So row 2 over 2 is 4 minus 3 is 1. And then the z goes here. And then row 2, this is 3 over 2. This is 3 over 2. You're dividing row 2 over 2, and this is part of row 2. So 3 over 2 plus 1. 1 is the same thing as 3 over 3. So that's 2 over 2, so that's 5 over 2. So we have 5 over 2. There's an equal sign. So far, so good? Now, look at the beauty of this. We're done. When you multiply, don't you go, let me change the color. When you multiply, don't you go row times column? Because this is a 3 by 3 times 3 by 1, so you'll get a 3 by 3 just like this one. What do you get here? 0 times x is 0, plus 0 times y is 0, plus 1 times z is what? Z equals 5 over 2. Bingo. We got the first one. We don't need zeros or ones like in any other places.
Why? I don't understand.
Because when you did the multiplication, you knock out the x and the y because you have zeros here. And then the second step, watch. Now do the multiplication on this one. Go row times column. Isn't that what you do? Okay, so 0 times x, 0. 6 times y, 6y, plus 8 times z, 8z, equals how much? 3. But you've already found the z.
Right.
Plug it here, find the y. So then we get 6y plus 8 times 5 over 2, correct? Equals 3. What's 8 times 5 over 2? You can simplify the 8 with the 2, so you get a 4. 4 times 5 is 20. Subtract 20 from both sides, so you get 6y equals 3 minus 20. You agree? Because I subtracted 20 from here and I subtracted 20 from here. So 3 minus 20 is minus 17, right? Equals 6y. So how much is y? Minus 17 over 6.
Right.
You just divide by 6. Bingo. So we got the second one. So minus 17 over 6.
Okay.
We got the z, we got the y. Now we go to the first column and we do the same exact thing we did. So this is x, 2y, 3z. Okay, so x plus 2y plus 3z equals how much? 1.
Right.
And I already have the y and the z. So I just plug them in and find the x. So y was minus 17 over 6. So 2 times minus 17 over 6 plus 3. And then what did we get for z? 5 halves. So times 5 halves equals 1. And now just simple math. So 2 over 6, you can simplify those 2 to 3's, correct? So you get x minus 17 over 3. And what's 3 times 5 halves? That's 3 over 1 times 5 over 2. 3 times 5 is 15. 15 over 2 equals 1. Now just add, or you could just combine these two. So, you know, common denominator of a 6. So, you can make the common denominator on the 1 as well, because at the end of the day, when you move those, you're going to end up with, you're going to have to add fractions. You like that shortcut or no? Okay, so let's just do these two then. Huh? You know, it's just making the process shorter. That's it.
Doesn't seem like it. I kind of get it. But
are you serious? We're done in like 3 minutes.
I don't get it. I don't get how to start it. I don't get how to set it up. I'm not getting it.
Yeah, basically the objective is very simple. The objective is, as long as I can get on the third row 2 zeros, the first two entries on the third row zeros, I can find my z.
You didn't do anything with them zeros. You just said they were 0.
No, I didn't. Look, I did 2 operations. I did minus 2 row 1 plus row 3, and then we did row 2 plus row 1. No, we have to, because naturally they're not zeros. You can't just make them zeros.
Right.
You have to make them zeros with, you know, with these steps. The only thing is, instead of doing 25 manipulations,
Right.
you do 3. You make this 0, and this 0, 3, and you're done. It's just a shortcut of the first process, nothing different. So here, common denominator of 6. So 6 divided by 3 is 2, times minus 17 is minus 34. And 6 divided by 2 is 3, times 15 is plus 45. So far so good. So x minus this equals 1. Okay?
79 over 6 minus x equals 1.
Right, so what's this? 45, 11 over 6. Because that's 34 plus, minus 34. Maybe I should split this up so it doesn't get confusing. So this is minus 34
Oh, there's no
plus, yeah, there's no minus sign. So
well,
minus, because this is a minus and this is a plus, so they stay as this. So minus 34 plus 45 is 11 over 6. Correct?
Right. Okay.
So equals 1. And now just add 11 over 6 to both sides.
Right.
So add 11 over 6 here. And add 11 over 6 here. These two guys go away. And we get x equals 1 plus 11 over 6. Common denominator. 6 over 6 plus 11 over 6. 17 over 6. Yeah. So x equals 17 over 6. Okay. So yeah, you know, it's just a matter of putting things together. Wait, something went wrong because the x is not correct. The y and the z are correct. Wait, what went wrong here? We did. Let's call 1 here. Y turned out to be minus 17 over 6, and z is 5 halves. So, and then the matrix was 1, 2, 3. Yeah. So, let's see. This is minus 17 over 3, and this is 15 over 2. So, 2 times 17 is 34, yeah? And then 3 times 15 is 45. So 45 minus 34 is 11. So 11 over 6. Oh, plus 11 over 6. Because 45 is bigger. We messed up with the sign.
Okay.
Plus 45 minus 34. Okay, so 11 over 6, then you subtract the 11 over 6. You don't add it. In case you reviewed this, so you have the right steps. So this is minus. And then we'd have 1 minus 11 over 6. Correct?
Mhm.
So common denominator, 6. So that's 6 over 6 minus 11 over 6 is minus 5 over 6. Now we have the right answer. Okay, so minus 5 over 6. So x is minus 5 over 6. You can see it took us like, this concludes the problem.
Right.
You know, let me turn this off.